my black hole lab. So there are two parts to this lab. Part one is to find the mass of a black hole using the motion of an orbiting star, and then part two is to determine the initial velocity of a spaceship to allow it to get close to the black hole without crashing. So I used a computational model on GlowScript to calculate these values. The fundamental physics principles that I used were various different equations within Newton's second law, such as I used F-net parallel and perpendicular equations in addition to the change in momentum equations. I also used the velocity and position update formulas and used the equation for gravitational force. I also assumed that F-net is equal to Fg, which is basically saying that the only force on the planet is the black hole. And then I used all of these equations to put into GlowScript so that GlowScript could calculate different values during different time iterations. So a quick overview of the result is that I found the mass of the hole to be about 1.48 times 10 to the 34 kilograms, and the ship's velocity to be negative 3.8 times 10 to the 7, comma 2.7 times 10 to the 6. So for part one, the mass of the black hole, the system is the planet and the surroundings are the black hole. The initial conditions were the mass of the star, and the initial velocity and position were created using the seed that was connected to my email account. So here are the code details for part one. We use GlowScript because it would be tedious to calculate the mass at every single iteration, so GlowScript just helps us do that faster. I plugged in all of the different Newton's equations to calculate different values of the star at different time iterations, and then set Fg equal to Fnet in order to solve for the mass of the black hole. And then the last section is just to see the vectors on GlowScript. So GlowScript calculated the mass at each time step. As you can see in the image where the black bar is highlighted, it was calculating the mass at every different timestamp. So in order to find a singular value for the mass of the black hole, I just averaged out all of those values to be about 1.48 times 10 to the 34 kilograms. So for part two, don't crash, the initial conditions were the star's mass, the black hole mass from the last part, and for the initial velocity for the ship, I basically just guessed and checked so that the ship wouldn't crash into either the black hole or the planet, and it would get close enough to the black hole and leave the system. So again, I plugged in the black hole mass and Newton's different equations into the GlowScript code, and basically this GlowScript code has an iterative process checking force, then velocity, then position, and then back again to create the orbital image of the planet and the ship. So in the GlowScript, I played around with the velocity values until the ship got close enough to the black hole without crashing, and so that it left the system. So you can see the pink line is the ship getting close to the black hole, and then it leaves. And then the blue line is the orbital image of the planet. So you can see that the ship got a distance of 1.2 times 10 to the 11 meters away from the black hole before leaving the system. So the difference between real life and the computer simulation is probably pretty big since the model doesn't take into account all the different factors that would influence this situation in real life. So for some sources of error is that this code assumes that the only forces are the black hole and the planet acting on the ship. And since I use trial and error to find the velocity, there probably is a more precise velocity that lets the ship get closer to the black hole. For the what does it mean question, Fnet and rate of change in momentum are equivalent, but the difference is on the information that you need to solve for the values. Fnet requires you to know all the different forces acting on a system, whereas the rate of change of momentum just requires you to know the change in velocity of a system. And for the what if you want to orbit the black hole question, you would need a y velocity slightly smaller than the orbital speed of the planet, but it needs enough x velocity to actually leave the planet and not crash into it or the black hole. So after some trial and error with the x value, I got this velocity, negative 3.5 times 10 to the 6th, comma 9.91 times 10 to the 6th to allow the ship to orbit. So you can see the pink line in this, the ship is creating an orbit around the black hole, and then again the planet is the blue line, which has its same orbit as before. Thank you so much for listening. Bye.